In this section, we're going to take a look at some basic word problems, identify variables and expressions to represent unknown quantities, write equations, and answer the question asked. Let's look at our first problem. 3/4 of a number is negative 81. What is the number? The first question you must answer when you're starting a word problem such as this is, what am I asked to solve? In this problem, we're asked to find some unknown quantity or number. So what we'll start out with is, we'll let our variable x, and again, choose any variable that you like, equal or represent the unknown number. That's very important when you set up any word problem. Always label your variables. Now that we've labeled our variables and we know that we're looking for some unknown number, our next job is to see what kind of an equation can we write involving our variable x. Let's read this again. 3/4 of remember means multiply, so 3/4 times some number, and that's unknown, that's our x, is, remember is translates to equals negative 81, which is negative 81. That looks like our equation. Let's write it down. 3/4 of means times the number, which we do not know, that's our x, is our equal sign, negative 81, simply negative 81. That's a pretty simple equation to solve. 3/4 x equals negative 81. To solve this equation for x, simply multiply both sides of the equation by the reciprocal here of 3/4, which is 4/3. Remember, the operation is really division. Dividing by 3/4 is the same as multiplying by 4/3. So we're going to multiply here on the left by 4/3, and whatever we do to the left-hand side of the equation, we're going to certainly do that to the right-hand side. This all divides out, and we get x equals, on the right-hand side, we have a little bit of arithmetic to do. 3 goes into 3 once, and into 81, let's see, that would make it 27 times. And notice that's negative 27, so negative 27 times a positive 4 gives us a total of negative 108. So, did we answer the question asked? We got x equals negative 108. The unknown number is negative 108. To make a quick check, all you have to do is take your original equation, which is 3/4 x equals negative 81, substitute the value that we found for x, which is negative 108, and then do the arithmetic. Is 3/4 of negative 108 equal to negative 81? It certainly is. Take the time to go ahead and check that on your own. Let's look at our second example. In this problem, we're going to translate the following to an equation. 2 less than triple a number is 49. Find the number. So again, we're looking for some unknown number. We'll again choose x to represent the unknown number. So let's let x represent that unknown number. Now, how can we involve x in an equation? 2 less than triple a number. 2 less than triple a number. Triple a number, 3 in that, minus 2. Now, it takes a little practice to understand these problems. If you're not translating as fast as I am, that's okay. Just keep practicing. The more you practice, the easier it will become. So again, 2 less, there's my 2 less, then triple my number is, keep in mind that is always translates to equals, and then 49. So there we have it. So our problem then boils down to solving this rather basic equation. To solve for x, we're going to add 2 to both sides. So 3x is equal to 49 plus 2, 51. Divide both sides by 3, and we can see that x is equal to 17. So what is my question asking me? Can I find the number such that 2 less than triple the number is equal to 49? I'm saying that that unknown number is equal to 17. Again, to make that check, take x equals 17, substitute into the original equation. That gives me 3 times 17 minus 2, as that equal to 49. And sure enough, you'll see that it does indeed work. So our unknown number in this problem was 17. Read the problem carefully, identify the unknown variable, write the equation, and solve. Let's look at our next problem. Sarah left the city to visit her aunt and uncle who live in a rural area north of the city. She traveled the 220-mile trip in 4 hours. On her way home, she took a slightly longer route, which measured 225 miles on the car odometer. The return trip took 4.5 hours. A. What was the average speed of the trip leaving the city? B. What was her average speed on her return trip? C. On which trip did she travel faster and by how much? Now that we've read the problem, let's see the facts. On Sarah's trip when she left the city to visit her aunt and uncle, she traveled 220 miles, and that trip took her 4 hours. When she returned home, she took a different route, which was a little longer, 225 miles, and that took her a little longer, 4.5 hours. Now the first question is, what was her average speed on her trip to the city or to visit her aunt and uncle? So problem A is we're asking for her average rate of travel. Now remember that rate times time is equal to distance. We're looking for R, her rate of travel. So we can solve this equation for R by dividing both sides of our equation by t, the time. So in other words, rate of travel in this case is equal to distance divided by time. Notice that the times divide out there. So if we want to find her rate of travel, we're going to take the distance she traveled and divide that by the time it took her. So in this case, our rate is equal to distance, 220 miles, divided by time. In this case, that was 4 hours. So when we make the calculation 220 divided by 4, we see that her rate of travel to the city, or to visit her aunt and uncle, was 55 miles per hour. Again, that was found simply by dividing 220 by 4. A second question asks us a similar thing. What was her average speed on her return trip? So for B, her average speed again, we're looking for her rate. This time, rate is equal to, again, distance divided by time. But on her return trip, the trip was a bit longer, 225 miles. So 225 goes in for distance. And her time on her return trip was again a bit longer, 4.5. So we're looking for her average rate of travel on her return trip. So 225 divided by 4.5 turns out to be 50 miles per hour. So we have found out by a simple calculation that Sarah drove at an average rate of 55 miles per hour to the city to visit her aunt and uncle, and when she returned, she drove at an average rate of 50 miles per hour, which brings us to our last question. Our last question asks the following. On which trip did she travel at a faster rate, and by how much? Well, I think it's obvious here to us that she's traveling faster to the city or to visit her aunt and uncle. So to answer the question, we'll say that she traveled faster to the city, and it also asks us to answer the question, how much faster? Well, if she traveled 55 miles per hour to the city, but only 50 miles per hour returning, then the difference, 55 minus 50, so that's 55 miles per hour, minus 50 miles per hour equals 5 miles per hour. So she drove 5 miles per hour faster to the city than on her return trip. So again, we use this basic equation up here that rate times time is equal to distance. Since we knew distance and time, we solved our equation for rate, which was the unknown in this problem. Once we solve this equation for rate, we can simply substitute the values for distance and time and then calculate her rate of travel. We did this twice for her trip to the city and on her return trip. And the third part of the question asked us which way did she travel fastest. Well, that's obvious when she was driving 55 miles per hour. And how much faster? Well, the difference between these two, 55 minus 50, or 5 miles per hour, tells us that on her return trip, on her trip to the city, she drove 5 miles per hour faster. Again, when you're doing these word problems, I encourage you not to feel discouraged, but to read the problems carefully, write down the facts that pop out, write equations that make sense, and just think a little.